In this video, let's look at dimensional analysis. So you might have heard about units and how important they were, and that every term in an equation should have the same units. So in this case, we will generalize that concept and look at dimensions. So you can say that dimensions are a generalization of units. It doesn't matter what units the numbers are in as long as it belongs to the same dimension. So anything measured in units of length has dimension L. So if we have distance t, then that will have a dimension of length denoted by L. Anything that is a distance or a length will have dimension L, and similarly anything that is measured in units of mass, be it in kilograms, grams, anything else that you might think of, has a dimension of m. So if you have a mass denoted by little m, then the dimension of that will be m for mass. So similarly, anything measured in units of time has dimension t for time. So if you have t indicating time, then it will have a dimension of time. If you have 1 over t, then that will have a dimension of 1 over time, and so on and so forth. So we are still looking at the three fundamental quantities: length, mass, and time. So anything here will have a dimension of L. Anything measuring mass will have a dimension of m. Anything measuring time will have a dimension of t. So now again, as always, if you have derived quantities, then we can use these letters L, T, and M to indicate the dimension of the derived quantity. So let's take a look at a few examples. Let's look at the equation of a straight line. Y equals mx plus h. Let's take the dimension of y to be L, so distance or length, and let's take the dimension of x to be L as well, so length or distance. And we have to find out the dimension of m and the dimension of h. So enclosing these letters in square brackets means that we are trying to look for its dimension. Given this equation, y equals mx plus h, this equation has three terms: y, mx, and h, and the dimension of each term has to be the same for this equation to be consistent. So we know that the dimension of y is L, the dimension of x is L, and the dimension of h is to be determined, but since we know that it has to be the same as the other terms, the dimension of h is also going to be L, length. What about m? So we know that the dimension of this whole term has to be L for this equation to be consistent, because h and y have dimension L, so mx has to have dimension L, which means the dimension of m times the dimension of x is L. So dimension of m is equal to L divided by L, which is 1, which means m is dimensionless because the unit is neither L or m or t, any of the standard ones. And from a straight line equation, we know that m is the slope of the line. So if both y and x are the same units, then m, the slope, would be dimensionless. So this is how you can calculate the dimension of any quantity in an equation. Alright, so now let us look at a complicated equation that includes exponents and trig functions and all that. So let's say y is ax plus bt plus c e to the negative alpha x plus d sine of omega t plus p. And let's say that we are given that the dimension of y is the same as the dimension of x, and they're both equal to L, and the dimension of t is t, time. Alright, so now we have to find the dimension of a, b, c, alpha, d, omega, and p. So you can basically just read off, since the dimension of y is given to be L, the dimension of p also has to be L, because each and every term in this equation has dimension L. So ax has dimension L, bt has dimension L, this one has dimension L, this whole thing has dimension L. Okay, so things to note: exponents and sine and cosine and trig functions are dimensionless, which means they have no units. Alright, so now this whole term, for example, has dimension L, and the sine term is dimensionless. That leaves us with d, and so that means d should have dimension L. Same thing here, the exponent is dimensionless, that means we are left with c, and since this whole thing has dimension L, that means c must have dimensions L. Alright, let's look at the bt term. So the bt term has to have dimension L for this equation to be consistent. Let's do the math. B times t is L. The dimension of b multiplied by the dimension of t is given to be big T. So big T is equal to L, and so that means the dimension of b is L over t. Alright, now let's look at the first term, ax. Again, the dimension of ax is L, which means the dimension of a times the dimension of x is L. The dimension of x is given to be L, so dimension of a times L is L, which means a is dimensionless, which means the dimension is 1. Alright, so all that's done. Let's look at alpha and omega. So e to the negative alpha x, the exponent here e to the negative alpha x has to be dimensionless, which means alpha x is equal to 1, which means dimension of alpha times L is equal to 1, so the dimension of alpha is 1 over L, which is the same as L inverse. So now let's do the same thing for omega t. The argument of a trigonometric function, which is omega t in this case, is also unitless, dimensionless. So omega t is dimensionless. So this means omega times dimension of t is equal to 1, and dimension of omega is 1 over t, which is the same as t inverse. Alright, so the important thing here, every term has to have the same dimension, and the exponents and trig functions and their arguments are dimensionless.